thanks for the introduction. I am Andrea. I created with some friends a tool called WordLift for automating SEO. And we do these using artificial intelligence and more specifically natural language processing and knowledge graph. So what we're going to see today, it's really, kind of something new that we've been working on. It's an experiment that we're starting to test on some clients, but it's also a way for us to learn about long tail SEO and SEO automation. So I hope that you find it useful, and there are some good ideas that you can take home and play with. Something happened and the marketing team dropped this slide into it, and also made a huge discount on our tool. So if you're not using WordLift already, that's the time. Cyber Week is going, and then I will stop any self promotion with this slide, and then we can dive into the content. So WordLift.io/cyberweek. It's a good tool. Use it. All right. So we have two sessions. So the first session is going to be more about understanding the concepts of long tail SEO. Whether, in the second session, I will be focusing more on looking at the code so that, you have something that you can use on your own website or use case. I like to keep these as interactive as possible. So as George say, if there are questions, so rise them up. And then George will let me know. So the plan for the day is to look at modern SEO, try to understand what does it mean, modern SEO, and then try to understand the importance of knowledge graph in automating some of the SEO tasks that can help us grow organic traffic. But our end goal for today is to build a long tail sales strategy. So something that will enable us to capture intents that are defined as long tail. So with a lower volume, but high, very specific type of search intent, and so potentially they are very interesting on different type of websites. In our case, we will look at a news website, but similar approach would apply to e-commerce and could apply to other type of sites. And we will use natural language processing and the knowledge graph that we will build together on a test website in order to find the best opportunities. The code that I'm going to use in this masterclass, it's written in Python, and it will be accessible to you over Google Colab. Google Colab is an environment where you can play with the code and you can copy my code and make changes, and so it's an opportunity to learn also a little bit more about Python when applied to the context of SEO. We will then analyze the results out of specific queries that we will target from Google, and we will try to dissect these results using natural language processing to understand, if there are tendencies, if there are things that we can learn from these results. And then we will also explore, the different ways in which we can generate content using transformer models, which are, it's a technology that allow us to do many different things. And among these many different things, we will explore the natural language generation part. And then we will look at the layout of the page, and we will see the page in the way in which we can create. So our goal is to at the end of it to be able to create pages that can go after long tail queries. So yeah, that's the first poll for you, so that we can kind of set the expectation and also know each other a little bit more. So I will let you run the poll. I don't know, Jane, are you sending the poll? Yes, I will be sharing the slides. I will be sharing the code, so don't worry about it. So let's take a moment for answering the question and try to set the expectation, but also to know each other and understand if if when I talk about long tail, you say, hey, what are you talking about, Andrea? Or if, that's pretty much granted. Okay. All right. This also helps me kind of understand a little bit about, how we should proceed with these. Okay. It looks like we have a good breakdown already. 80-20. And half of the room has answered already. Okay, I think we can share the result, and I can get back on. I think it's clear that we know what we're talking about, but I shouldn't get too technical. And if I get too technical, you just you stop me, and then you ask me for more information or explanation. So as we do this journey, we will tap into different technologies that are currently used within the context of modern SEO and what I like to call the AI-powered SEO. So as we said, we will use the transformer in order to generate content, and more specifically, we will use the transformer and a language model that it's called Google T5 that's been worked on by Google and created from a very large corpus of text that comes from the Common Crawl dataset. So we will use T5 in order to generate an abstract summary of that we will use as part of the content of the page that we are creating. We will build the knowledge graph. So the knowledge graph is pretty much built already, but I will, give you a quick overview of WordLift and the way in which, we are building the knowledge graph that we're going to use in this session. And then we will learn about embeddings, and more specifically about knowledge graph embeddings. This is really a silver bullet for, any SEO working with data, because it's a fast way of accessing to the data inside the knowledge graph to make a very quick decision. And taking quick decision is super important when you do SEO. Sometimes it's like a consumer that has jumped on a page, and then you need to bring it to the funnel, or maybe you just want to have him read something more interesting about it. So taking fast decision is crucial, and knowledge graph embeddings are a fantastic tool to do this. So we will try to see a little bit about what they are, how they work, and then we will play together with the embeddings. And then we will move into looking at Google search results, and we'll try to set the methodology that we want to use for analyzing Google results. And we will do this using name entity recognition and the knowledge graph that we have built from the website that we will use during this demonstration. And this will lead us to intent discovery. So a way in which we can try to provide some seeds, some ideas, and look into potential search intents that come out of these ideas. This is very powerful because, of course, when we want to do a long tail strategy, we need to understand exactly what needs to be covered. What is what type of intent should we cover that our site is not already covering, and that at the same time I have enough content to cover, because that's another big challenge. Because I want to create new content that will untap new opportunities. But of course, I have to be meaningful to the end user, and so I have to have content about it, and possibly I shouldn't cover something that I am already covering with the content that I have on my site. And then we will use again Google T5 for another approach to text generation, which is based on the question and answer generation. So we will generate the question. We will try to see, what are the most frequent questions, and we will see two ways of doing this, because there are two ways, and then we will try to understand, what is the best way, and then, at the end of this journey, then hopefully we will, unlock the treasure and get traffic. So, what are the problems that we want to solve in the end? I mean, what type of issues do we face when building a long tail sales strategy? So the first problem is that we want to identify new areas of search demand. So understanding something that we are not currently covering, or that we could cover in a much more effective way. And then these already entice the fact that we need to analyze the content that we have already on our website. And to these, there is another small problem connected to it, which is analyzing, the intents that we are already covering within the context of our website. We will not indulge into these further refinement, but it's important for you to know that, of course, you don't want to cannibalize existing traffic with a long tail strategy. They would be pretty bad for your overall organic presence. So in the end, we want to find the best match between what Google expects, so that the interpretation that Google has of that intent, and the content that we have. So these are the three key areas of the the two classes that we are going through today. So let's start with the first question, and here I start to play a little bit with natural language generation.
Andrea, excuse me for the interruption, but in switching the screen to the polls, we missed your slides. So can you reshare your screen, please?
Sure.
Thank you.
Hi, Julian. I see you're here. Okay, so how do I do it? So I'm stop this, and I'm gonna share it again. Do you see my screen now?
Yes. Yeah.
You do, okay. So you didn't see the treasure map?
No.
That was one of my best slides. Okay, so briefly, content summarization is going to be one of the technology approaches that we're going to use. Knowledge graph creation, and then of course we will see how to create this knowledge graph using WordLift. Knowledge graph embeddings, as we say, the silver bullet for a lot of decision that you need to take in order to understand how related concepts are. And then a natural language processing for analyzing the results coming out of Google in order to discover new untapped opportunities. And then we will have one more digression on another natural language generation technique, which is also using Google T5, but in this case, T5 is trained for generating questions, and then we will see that we can also train it for providing the answer to these questions. So problems that we want to solve, just quickly, getting new areas of search demand, analyzing the content that we have already on our website, and then find the best matches, the best match between the content that Google expects and the content that we have on our website. So these are, the three challenges that we are going to face. There is, one hidden challenge that you will also need to face if you start to implement your, semi-automated long-tail strategy. That is, of course, what is required to create content that doesn't cannibalize existing content that you may have. But we will not look into these, but of course, I have different ideas and ways in which can be addressed, but we will focus on these three main aspects. So here I'm starting to play with the transformers so that you can familiarize with the type of content that we can generate, and the way it works, and the limits. So on the upper side of the screen, you see the question that I have provided here to the model, and then on the output you see the answer that I get out of these. And I always start, questioning if SEO is dead, especially at the end of the year. That's one of the, things that, usually gets debated at the end of every year. Like, is SEO still relevant, or is SEO going to be, a thing in 2021? And the answer that I get, it's a quite good one, because it says that, SEO is still a driver of traffic and leads to your website, whether you invested in SEO early or you're just getting started. And what is interesting is that I process these answers with Grammarly in order to see if this content appears to be plagiarized. And in this case, Grammarly tells me that only 9% of these text matches another sources, which is okay. I mean, of course, it's small sentences, as you can see, but 9%, it means that, it's quite genuine. And I like the answer after all, so I made a slide out of it. So you can see that I'm starting to make the presentation with the computer. So now, what is modern SEO, or what does the machine think of modern SEO? And here I'm going to read the answer. The answer is: a search engine optimization specialist can be described as someone who helps users find what they're searching for when using search engines like Google and Bing. However, a modern SEO specialist must be able to make decisions quickly and effectively. Now, as you can see here, the text is a little bit more plagiarized than the previous one, but I really like it a lot, because it kind of makes a, long sentence for introducing search engine optimization, and then it kind of kicks in with the definition of modern SEO, which is specifically defined as a skill that a marketer has when it can make decision quickly and effectively. And that's the vision that I have about SEO and artificial intelligence. An AI-driven SEO specialist is someone that takes decision quickly and effectively. And while as the people that know me, I have no plans in removing marketers and SEOs, I do believe that we could get a lot of powers if we start to use on our daily marketing job these technologies in order to scale up the traffic that we create. So as I was, getting good results, then I started to, keep on asking questions, and I end up in asking, what is modern SEO in 2020 then? And then I got another answer, which is also interesting. So senior SEO scientist Brittany Mueller, that you might know, Brittany is a brilliant SEO, probably one of the best and earliest SEO that has been working in the context of machine learning. And so Brittany Mueller, the machine continues, offers a list of 17 things that you should keep in mind for effective SEO in 2020. These include title tags, meta description, alt text, site speed, robots.txt, sitemaps, UX, conversion rate optimization, analytics, etc. Schema, markup, FAQ, breadcrumbs, news, business info, etc. I think we will see these types of markup types continue to grow. Now, this one doesn't look, as good as the others, but it's interesting because the model is bringing up, a specialist, a person, very well-known figure in the SEO world, in order to, kind of bring something that some relevancy into the answer. And Did you notice something odd in these? I mean, besides a little bit of grammatical mistakes, I mean, is there something that, that doesn't sound right? So yes. So one thing besides, the grammatical form that could be optimized, but definitely it's not the worst thing. One thing that we can notice is that the text that has been used for describing, modern SEO is originally composed of 17 things, but that if we go out and count the different factors that are listed, we get a couple of etc., and then we get 13 things. And so one of the aspects that we see here is that in reality, a language model doesn't really understand. At least it cannot count. For the very least, it's not able to count properly. And so that's one first important point of this session, is that the transformer, which are these new architecture in the deep learning world that has so much and greatly advanced natural language processing, among other areas of deep learning, it did unlock a lot of new opportunities in the SEO space. So I can make slides. Last year when I was at the Connected Data event, I wasn't able to do something like this. I wouldn't have been able to create these slides. So these are new SEO opportunities. But at the same time, these language models are still limited, and we need to understand the limitation in order to use them in an effective way. So Gary Marcus, that is also attending this event, and it's a brilliant researcher and an inventor and startupper. So a lot of you will read a lot about him. Say that language models don't know what they're talking about, and that's precisely the problem. So there is language models are a good approximation of an understanding of what language is used, but they are very far from understanding language itself, and that's a slight difference. But it will impact a lot in the work that we're going to do today, and in the work that we can do in SEO at this specific point in time with natural language generation. So we have a new, So we've seen a progress of language models that have a super high number of parameters, and inside a language model, the parameters identifies the complexity, and it's also representative of the enormous amount of data that it's used for creating these models. As we said, we are going to use T5, which has been produced in Google, just the beginning of the end of the it was presented at the end of last year, and it's been trained on Common Crawl, which is one of the biggest data set of the web, of the web that can be crawled, that is available to date. So these billion parameters language models kind of are capable of predicting the next sentence or predicting the next word, and are trained on a lot of machinery that it still costs a lot of money, and it costs a lot of natural resources. So the training of GPT-3, which is probably the most well-known language model to date for content generation, has required something like $4.6 million for training. Now, this also means that when we are going to touch these models, there is a high degrees of complexity, and whether the libraries that we use are making super accessible these technologies, we have to keep in mind that as we try to personalize or to fine tune these models, we will need a lot of resources, and so we will need to make sure that that's what we need, and that this is exactly what will create the success in our SEO strategy. So there's been a great evolution of language model. They are super complex. They take a lot of energy and resources to be created in the first place, and they will also require a lot of time for you to fine tune them and train them to your specific goals. And this means that there are still a lot of barriers, regardless of the fact that, yes, there are super accessible software libraries that allows you to do great things with these language models. Like you can start using GP3 for writing a program in Python, or to create your next HTML page. You can fine tune and provide inputs to a language model, and you can obtain that result. But there are still great barriers that we need to consider. So there is a new poll that I will ask you to answer, and then we can take a short break of a couple of minutes, so that we can kind of relax, look outside and stretch and do whatever we need to get started again. So let's run the poll while we do this. And I can also read a little bit about the question. Ace, I have seen GPT-3 in use, but I haven't used it myself. So I haven't. I've read a lot about it. I've read a lot about different use cases, but I haven't used it myself. All right, good. So I see that everyone is still following. So I can share a little bit of the results that we get, and then we can start again the session. So what are the limits of today's language models? They are good at predicting the next word, but have trouble in encoding knowledge because they don't understand really what we're talking about. So yeah, so that's a little bit the lesson learned so far about generating content with language models. All right, so I will resume the presentation. Do you see my screen?
Not yet.
Okay, so let me stop and then start again. Yeah, so I have to do this. Okay. All right, so you should see now.
Yeah, it's fine now.
Okay, good. All right. So let's wrap it up. Pre-trained language models, BERT-like, that have come after BERT, that has been, probably the most well-known language model in the context of SEO, because both Google and Bing announced already last year that they were using BERT within their technology stack. But pre-trained language models like BERT and whatever came after until recently can only handle a limited input text. So that's kind of an important aspect. The way in which the language model focused the attention on what what is important of the text that we are providing is somehow limited by the fact that this mechanism called attention is quadratic to the sequence length. So it just goes up immediately as we provide more text, okay? So this fundamentally creates a limit to the maximum length of the input sequence that you can provide to the model. And these can be, 512 or 1024 tokens, and a token is, pretty much can be seen as a word. Okay, so the first limit that we have when we use language model is that until the recently announced models like BERT and other, and I think Microsoft has its own kind of BERT-like model that use a sparse mechanism. When you look at a model that is using the attention mechanism that prevailed among other techniques used for generating content, then you are dealing with a machine that can only take every step a maximum of 512 tokens. Now, this might not be a big issue because, of course, you can split the content into multiple paths and then, send it to the model in parallel. So there are ways of coming out of this problem. But, of course, it's a limit that it also impacts, the use cases that we can, implement with these language models. They are super good at predicting the next word because they have read, a universe made of content. They have read the entire web, not only Wikipedia as it was, for the first one, like BERT and whatever came after. But if you look at T5 has been trained on a corpus of text that basically it resembles pretty much the entire World Wide Web. So they are super good at predicting what's coming next, and we're using it already inside, a Gmail or our, favorite text editor on our phone. So they're super good at, predicting what's coming next, but they don't understand exactly what we're talking about. They cannot encode knowledge, and one example was that, as we saw, they cannot count. Right, so they're limited in the number of operations that they can do. They are also limited in terms of generalizability. What does it mean? I mean that it's very hard to generalize a language model. So if we want to get a good result for a specific content, we might need to train them or to fine tune it. Now, fine tune it means that I can use whatever language model has been pre-trained, but I will have to make it more special for my specific knowledge domain, because they are not good at working across different domains. And so if I train something on, let's say, a website of soccer games, then I will not be able to reuse the same model for let's say a website on medical terms. So they lack this ability to generalize that of course it makes it more complicated to implement it, because I have to create something that is specific for that content and for that website. Fine-tuning is becoming at the same time very simple to make, because libraries like the libraries that we're going to use are very practical, super easy to use, and so it's becoming kind of a new way of forking. Like when you go get the code and then you kind of play with the code yourself and you create something new. So you can fine tune these language models, but at the same time it does require a lot of efforts. Creating personalizing your language model, it can take it takes a lot of trial and errors to get it right in the first place, but it also takes a lot of resources from the computational point of view. And just to give you an idea, we trained internally a summarizer using T5 for the German language, and in order to do like a very basic retraining, it takes something like between 4 and 5 hours. And you need to have a lot of memory, and most importantly, you need to have a lot of training data. So yes, you can personalize this language model to achieve whatever you're trying to achieve, but you need resources, and above all, you need a lot of training data. So yeah, that's for all of my client. I created a video using these AI, and the video goes on and says, let me see. All right, so that's just a kind of a thing to remember, that this language model will not replace your editor. So stop asking me about removing your editorial team. It's not going to happen. And yeah, so I mean, things that we want to point out is that we need to create technologies that can augment what we do on our content. There's no way for us to at this point to totally replace the human being. Though we might achieve in kind of complementing what the human is writing with some small paragraphs, or some more questions. So we will see some practical examples coming up of the things that we can do realistically with this new language model. So we'll now move into kind of a quick overview of the knowledge graph that I built for this workshop. But first of all, of course, we need to introduce what is a knowledge graph. And I like to go with with a very simple justified true belief theory that it's attributed to Plato. Whether it's true or not, I will also use the justified true belief. So that means that basically, if a person has a belief, and if the belief is true, then the person is justifying in believing whatever is believing. And these will produce knowledge. So the simple explanation of what a knowledge graph is that everything that you believe to be true, or someone believes to be true, it becomes knowledgeable. It becomes a fact, and that's exactly what we see, especially when we look at these very large graphs like the Google Knowledge Graph. I mean, whatever is said there, people accept it to be the truth, and therefore it produces knowledge. So a knowledge graph, it's a way of representing in a data structure a justified true belief. And of course, now we will not get into the debate of if this is right or wrong, but just so you know, a knowledge graph, it's a data structure that describes facts. Okay, and that is a list, a definition that we will use during this workshop for knowledge graph. Now, how do we build a knowledge graph? Because there are so many different ways in which we can tell facts, right? But in this specific context, we start from your website. We start from web content, and here I've taken kind of an inspiration from a slide by Teodora Petkova, and she took an inspiration from our website, the WorldLift.io website, and here we see that the web content that we published becomes linked data. And so this is a characteristic of what WorldLift does, but it's also kind of part of the evolution of modern search, where we start to use structured data to describe the content that we published on our website, and this is creating a graph. Okay, so here we have a blog post, which is the Apology of Socrates, that references Plato, and it references Socrates, and it references the Socratic dialogue, and it's been authored by, in this case, Gennaro, who's, I'm not sure if it's attending today, but it's part of the WordLift team. So the web content is for us the source of truth that we are going to use to build the knowledge graph. Okay. And we do this using a linked data vocabulary that is called schema.org. As you might know, linked data allow us to freely use any type of vocabulary, but we focus on schema because schema is the vocabulary that has been created by the search engine for understanding the content on the web. So it's been developed by and for the search engine. It's a super extensible, and it's continuously growing, and it's become, de facto the standard for linked data. So there is a lot of, there's an open community. There is, of course, also a lot of debates on, the role of Google inside this community. Maybe it's too strong, maybe it's too weak, but there is a lot of, in practice, there is a lot of opportunities for you to get into the arena and sustain the growth of the vocabulary that today consists of 841 types. And so different classes. So there are 841 different type of things that we can structure using today schema.org vocabulary. So that's super powerful, and that's the language that we use for creating the facts inside the knowledge graph, starting from a website. Okay, and I hope that you're still following me, but. To make it super simple, we create information in the form of triples by combining subject, predicate, and object. Okay, and we do this using the schema vocabulary. And so, on a structured text like Jason Barnard, knows, and Volpini will eventually become inside the knowledge graph. A triple. So subject, Jason Barnard, predicate, knows, object, Andrea Volpini. So the text become triples, and then the triples get expressed in the form of structured data. So we use, the schema.org vocabulary for creating these for representing these triples. But then in the context of WordLift and other tools like WordLift, then we convert the structured data into structured linked data, where everything has a unique identifiers. And that's becoming more important, even though Google doesn't acknowledge that it's using these unique identifiers. We have seen now across these 4 years that we've been in the business with WordLift that Google is somehow using these unique identifiers. These are particularly interesting because they start to represent your own sitemap. Because if you provide an ID for every concept that you deal with, and you start reusing this ID across multiple pages, it makes it very simple for the search engine to index and to understand your content. So we start from the triples, and we transform the natural language into these triples, and then we publish this triple using linked data. And as we do this, we provide a home to each entity by publishing the linked data URI. So in this case, we can see the entity for Jason Barnard, who was with me yesterday in the panel, and that has been published using WordLift, and that can be linked from Wikidata because it's accessible, and it's in the published as linked data, and so then we can query this entity also from the Wikidata Sparkle endpoint. So we can start combining data, our data with the public available data, and then we create these large graphs that we can use for different things. And that's exactly what we're going to do in order to create the long tail pages that we want to build for, capturing new intents. So it's now time to meet a little bit George, who is with us and has made the introduction. Because in order to build these demonstration today, I have asked permission to George, who is also not only among the organizers of this conference, but is also a brilliant journalist for ZDNet. And I asked this permission in order to use his content for creating a demo website. And to build a knowledge graph out of his content, and then to start using this knowledge graph to create, the long tail strategy that I have in mind. So let's start to word lift a little bit of George's content. So I will quickly move from the presentation into WordPress. Let me see if there are some question here. What visualizer is this? Colin is asking. I don't know. Try to explain me what slides you were referring to, and I will try to answer. Yeah, let me see if Colin respond. So you mean this one? This stuff here? If it's this one, I'm visualizing data using Wikidata tools. So this is a tool that is a part of the Wikidata Sparkle endpoint. Yeah. So if that is what you're looking for, all right. So I will quickly jump on WordPress. I'm confident that you're still seeing my screen. And here you can see I have 74 blog posts that have been copied from ZDNet, and they are all written by George. And so that's an example of a post, and you can see that the text has these highlighting, and these are the annotation that have been added using WordLift. That it's now here encapsulated inside WordPress. So that's the CMS that we're using. It's called WordPress. And here we have the list of entities that are organized into different groups, and for each entity, then the editor can kind of edit the content that it's represented for that concept, and it can also place eventually a link to these concept pages, to these kind of imagine it as a glossary of terms. And then as the editor kind of checks these entities that to highlight the one that are relevant, is building the knowledge graph. Okay, so we have the blog post, and then we have the entities that are used for the annotation, that provide the context for the blog post. And then you can see that automatically the tool is kind of getting some images from the other content that has been published inside this knowledge graph, and then it's also providing kind of a list of related articles that can be used. So we have this entity annotation process that it's already creating an impact in the SEO, because it's publishing data as we saw in the form of structured link data. But we can also tap into the user experience by adding some widgets. So if I use these shortcode and I add these, then we can have a quick look at how the front end changes. And so here we have the links that have been created by WordLift that have these, we call it context card, which is sort of an explainer text for a concept that I might not be aware of, like deep learning or machine learning, or simply in my case, I want to understand how George defines machine learnings, because we might agree or might not, but I think we do. Okay, so and here I have I've placed a widget that as you can see is a list of related articles, but I can organize these using this network of entities that now I have created, so that I can have a look at things that are, for instance, related to machine learning and COVID-19. So I'm using the entities of the knowledge graph already in the front end to create an interaction with the user and to let the user explore new content. So what is important out of this is that we see that the knowledge graph has been built by choosing the entities that among the entities suggested by the tool that we think are relevant. Okay, and that's the SEO work. The SEO work is really becoming more and more about curating the content. So there was probably a quick demo of the tool, but it's what is necessary to understand more about how we're building the knowledge graph. Okay, any plans to offer a version of okay, well, so far so good. The slide, the show Plato's connections. Okay, yes. So that's the slide I use, the show Plato's connection to answer to a question coming from Collins. It's a tool called Log Live. It's a terrific tool, but unfortunately, the developer, who is also a friend of ours, is started to work in fintech. So the semantic web community has lost its contribution, and the tool is currently no longer maintained. So we used to have it directly linked in WordLift, but it's no longer available because the guy that developed it it's focusing on other stuff. Any plans to offer a version of WordLift for Jamstack? Yes, I mean, WordLift is not only available to WordPress. I mean, it used to be, but we currently have a JavaScript library that can help you improve the content outside of WordPress, and so yeah, no worries about it. But back to us, because I think it's important that we get a concept more than the tool. So we have taken 73 articles from George's latest stories on ZDNet, and we have created this knowledge graph that it's made of triples, and so the simplest form of the knowledge graph that WordLift creates is the one that we are dealing with today. So the subject, the predicate, and the object, it's always an article that contains a reference to a concept. Okay, so that's the structure of the knowledge graph that we have created with the content written by George. So as an example, we have an article which is has its own unique ID in the linked data world, which is this one, and that mentions, among other concepts, the entity for deep learning that within this graph has its own unique ID. Okay, so that's how we have created the knowledge graph, starting from the content that George has written. We could be way more structured than these, but of course this is kind of out of the scope of today's goal of creating a long tail strategy. But just so you know, you can build a richer knowledge graph by creating a more structured content model for your content. And so you might have, for instance, an object that can be a webinar that has its own author. And so there is a typed relationship within the author of the webinar, and the webinar itself is a creative work. And so you can really kind of expand deeply into the realms of content modeling and create a, fantastic over-structured knowledge graph. But here we have a very simple version that has articles and then concepts linked together through a schema property called mentions. So here we start to kind of dig into the code, and I'm going to actually run the code. So we will take another minute break, and I will start running the code here so that we can try to see how we're getting to this kind of breakdown of the main concept that George has talked about in the latest articles he has written for ZDNet. And yeah, 1 minute break, and we will get back here. All right, I'm back. I hope you're still following me. And so we will start to look at the code. We will have the upcoming session on kind of the way in which this demo has been constructed. So I will just show you a little bit of the way in which the code is organized. So here we have what I call the inspector for the intent. So the tool that we're building in order to seed the different areas of search demand that we want to create using based on the content that George has written. Here we are actually choosing some of the ideas that we want to analyze in order to find things that we could write about with our, with this new tool that we are about to build. So as you can see here, I've added machine learning, artificial intelligence, and knowledge graph. And so here, we will see in the next session, we tap into a specific country, which in this case is US, and we use a specific language, and then we use this snippet of code, this function, in order to explore the suggestion coming from Google Autocomplete. So, but at this point, as we've seen, we have analyzed the sitemap of the website that we have built with the content from George, and we are running a name entity recognition on the sitemap to get the top entities from this website. And so here it's where I read the sitemap, and then this is where I start counting for each article the top 5 entities, and then I group them all together, and I try to understand, where are the things that George is talking about the most. Okay, so that's the process that I use for getting this list of entities in the slide that kind of provides us with some ideas about the content that we have on our website. Okay, so you can ask me then questions about this process and how to apply to your own website. It's quite interesting because it allows you to analyze also the site of a competitor using the entities that you have inside your own knowledge graph, or entities that might be available in open graphs like DBpedia or Wikidata, or any type of link data graph that you might have access to. So a lot of the concept that George uses is kind of revolves around of course data, knowledge graph, and then the various technologies and frameworks of related to knowledge management, decision making, and artificial intelligence. And I needed to see these in order to be able to provide the original ideas to the system that will provide me with the list of long tail intents. Okay, so I need to know that I'm covering, let's say, cryptocurrency, or doctors, or sneakers, or sunglasses. So I need to have kind of an idea of what content I can explore when I look for a long tail intent. And so these are kind of the top entities in terms of occurrences from the content that we have on our demo website. And here we start to look at graph embeddings, and that's the really kind of a 101 introduction. Don't expect anything too deep, but should be good enough to understand what are embeddings and how we can use embeddings once we have built a knowledge graph like the one that we have created from the WordPress website using WordLift that connects every article with its top concepts. So here we have Notorious. We'll try not to push it too much because otherwise Ace. So the reason I choose this song from a well-known rapper is that yeah, I mean it's one of the biggest rapper of all times, and but this song is called "What's Beef," and here there is a very interesting play of homophones, because as you can see, he writes "Beef is what I see you, but guaranteed to be in ICU." And now it's of course it's given the pandemic, everyone knows what an ICU is, unfortunately, and so the acronym for an intensive care unit, but it sounds the same, but it has completely different meanings. So ICU can be I see you, but it can be also intensive care unit. So again, yes, I like hardcore, hip hop, and rap, but the reason I've chosen this song is that there is a very a great deal of ambiguity, not only in the terms, but also the way that each word sound can be ambiguous and hard to interpret. So in order to understand the concepts behind a song like that, we can use something called distributional semantics, and here we have John Rupert, who is kind of an important leading figure in the British linguistics from the 50s. And it's been foundational for a lot of the work that it's done today in the context of NLP. And distributional semantics is the science that understands and studies ways in which we can quantify and categorize semantic similarities between linguistic terms by looking at their distribution. And their distribution within a large corpus of text allow us to understand their meanings. That's the explanation of distributional semantics. So this is a famous quote by John Firth that says, "You shall know a word by the company it keeps." Okay, so by analyzing the way in which the word is placed and the word around the so-called context window, we can understand its meaning. But as we move into from word embedding into graph embeddings, then we can simply replace word with entity, because with graph embeddings we're doing exactly the same process of converting an entity. I mean, in word embeddings we convert a word into numbers, and with graph embeddings we convert entities into numbers by looking at what? By looking at what entities are around that entity. So if in distributional semantics we look at the words that will accompany other words, and we try to look at the context window as the words around that same word that we're looking at. In graph embeddings, we look at entities and edges around these entities that create kind of the closest network. Because again, our goal is to be able to find the semantic similarities. That's what embeddings are good for. So what's beef? So, and you can see here that, we have a similar structure, right? But then there are so many different, interpretation of the same concept. So beef is when you make your enemy start your Jeep, but beef is when you roll no less than 30 deep. Beef is when I see you guaranteed to be in ICU. So the same construct is, different distribution. And they have similar meanings or very different meanings in some cases. So the goal of distributional semantics is to understand within the context window what are the core occurrences, and therefore take out the meanings. And with graph embeddings we do the same, but we don't use words, we use entities. And so we convert these entities and their relationships into vectors. And these vectors are meant to help us understand the distance, okay? And imagine the distance between point A and point B can be measured, with a very simple function. But we could do the same in a three-dimensional space. We just have to, calculate, how the distance, would change on another axis. And imagine that in graph embeddings we have multiple dimensions. So we can calculate this distance across, let's say, 412 dimensions. And these allow us to quickly understand what's close to what within our graph, and it allows us to take the fast decision that we need to take as automated SEO in order to build our long tail strategy. So let's have a quick look at the embeddings that I have created from George knowledge graph. So here, we can kind of point a concept that can be, for instance, artificial intelligence in this case. And it's at the center of, other stuff that, other concepts that are kind of related and close. And you can see here, for instance, TensorFlow and, let's see here. Here we see computer hardware, knowledge, machine learning, neural networks, deep learning. And that's very interesting because, here you see that we're kind of visualizing these embeddings. And we see here, for instance, there is a kind of a uniform group. So these are the blog posts. These are the blog posts that George has written, right? Whether these are, the network of entities that we are using for classifying this post. Okay, so what is interesting is that I can quickly operate a similarity function to understand what is closer to what, okay? So I can look at deep learning and I can see that it's, very closely related or somehow closely related with cloud computing. And of course with the concept of knowledge and with the broader concept of artificial intelligence and we can do this also, let's say, with Gary Marcus that we saw before in the presentation, and we can see that it's somehow closest to hybrid system, to the statistical analysis that he discussed, and then of course decision making. And so we can kind of start to take decisions with these embeddings because we can quickly see what is the closest concept that we have within the context of our knowledge graph. So how do we use it practically? Okay, so there is a way to create these embeddings. So out of a knowledge graph, I look at all the triples, and then I use a library and an algorithm for building these embeddings. And then I can act on these embeddings. And I can, for instance, look at what is the closely related concept to the concept that I have already, or what is the shortest path from one concept to another. But I can also use it for adding additional property or additional annotation that I might have missed inside my graph. So we can also use it for unbiasing George, because George writes a lot about, of course, artificial intelligence. And here, as you can see, I have kind of placed on the right side everything related to Microsoft, and on the left side everything that is related to Google, and then on the top side, everything that is related to machine learning, and on the bottom everything related to deep learning. And we can see clearly that George is a little bit biased towards Google rather than Microsoft. George, I don't know if you agree with these, but that's the way that we saw it from the embeddings. All right. So why are we using embeddings? We're using embeddings because we want to find a way in which we can interpret the content that we have on a website, and then now it's the time to start looking at the content that we get behind a specific intent. Okay. Quickly, next session we will kind of get more into the code, but this is a library that I use, which is called AmpliGraph, that I use for setting these, creating these embeddings. So basically, it's machine learning. So you provide all the triples from your graph, and then a model gets trained. And then you will start running inferencing over this model. And for instance, you can predict new links, which is not what I did in this case. You can visualize the embeddings, which is what I just showed you. But you can also use it for instance, discovering facts that you don't have. And here, for instance, you can see that there is an article about IBM Watson that has to do with cognitive systems for population health, and the embeddings is helping me recommending to annotate these with healthcare. Okay, so I can kind of use the embeddings also once I've done the first annotation to suggest to the editors, annotation that might be added to that specific article. And you can see the same it's done for these other article that it's about COVID-19, where, you know, the embeddings are suggesting me that maybe I should tag also, you know, I should use also the entity healthcare for this article here. So we can use embeddings for predicting terms. All right, computer says no. Interesting. Let me see, because George is actually responding. If there is a topic expansion apply here, don't recall it about lockdown, for example. I don't know what we copied, George. That's the problem. I mean, I don't know. I mean, I have to be honest. We scraped starting from the list of articles on ZDNet, but we might have got also some articles that are not coming from you. That's that could be the case.
Okay, that explains, because I'm like, okay, when did I write this stuff?
It could be. I don't know if yeah. So we grabbed some articles which we thought it was were from you, but yeah. Okay. Sometimes, you know, we get smarter than we think with machines. You know, sometimes we just copy someone else's content. All right, so so back to us. So now we are kind of looking at Google, right? So we have seen that we can get the content and create a knowledge graph from the content within the website, and then we can see that we have this super powerful tool called graph embeddings that allow us to find the shortest path or to find matches, let's say, even if there are no close matches, right? And now I want to start looking at the results over Google for the potential query that we could target. But to do this, I first want to you know, kind of define the methodology that we're going to use, because I've seen a lot of SEOs, you know, looking at correlation studies or creating correlation studies and analyzing a lot of queries. And I mean, a lot of the tools that we use, from SEMrush to, you know, Ahrefs and Alexa, or, you know, mods, you name it, have, you know, a lot of data about the search engine result pages. Now, the problem is the way in which you pretend to understand these results. And so I thought that you know, I found extremely important to define the methodology that you're going to use. And in reality, a lot of the SEO, it's kind of built on positivism. And positivism, it kind of finds and looks for universal laws. But in reality, in SEO, there are no universal laws that you can apply. And the only way that I found effective is to look for the causal mechanism that can act as tendency. So we can not look for correlations between, you know, if this, then that type of stuff, because it just doesn't apply. But we can look for tendencies. We can look for things that might be like that within our own context. So there is no way that you can generalize, you know, the analysis of the results of Google and say, hey, I know that if you do this, then that. No, there's no way, because in the end, on the other side, you have a lot of different machine learning algorithms that are processing the data and that are getting, the inside their feedback loop, whatever interaction the user makes with these results. And so it's very hard to kind of come up and say, hey, you should do an H2 like this, or you should write a meta description like that. All of these things, all of these factors are somehow helpful, but you have to realize that, well, you cannot be theory dependent. So there are people that say, yeah, if you do meta description, then you get more clicks. That's true, but that's also a theory that can be proven wrong in a lot of cases. And you cannot do like, if you do the H1 that matches the query, then you're going to rank first. Because there's no universal law that says that, a match on match with the H1 or the title will give you better ranking to a page. So how do you do it? Because of course you cannot go after, case by case and query by query when, like in this case, we're analyzing, hundreds of potential queries to rank for. So my approach is to kind of be a critical realist, which means that you can only look for tendencies, and then you can act upon these tendencies, knowing that, of course, you can generalize within your context, within your domain, but there's not really a way to kind of make it universal. I cannot build a tool. I cannot say, come to you and say, hey, WordLift will make you rank #1. Because I can only look at the tendency, and I can say, hey, with these type of, parameters, you might, have more options to rank. And so this approach means that we kind of start to look from the results, and then we try to decode the results and understand the way in which we can build the page that we want for ranking on that specific query. And again, I used AI to provide an answer to a very complex question, which is how does search engine index how does a search engine index the web? And it's important that we get these out of the picture, because of course it's a crucial part, but it's not what we're going to cover. So a search engine, when a user enters a query, it will present results that are coming out of an index that has already hierarchically organized the pages into set of results. And then these ranking algorithm will present the results to the user, and then the user will select an option from this list of results. And this action of the user, along with subsequent activities like how much time the user spends on the page, and so on and so forth, are fed back into the machine for future learning, which might affect the results the next time. Okay, so the way in which the search engine gets the results in the first place is by looking at pages that are more relevant for the user intent, which might or might not correspond with the query, because the user intent might group indeed multiple queries. And so the entities that we can detect from the list of results gives us the power to kind of interpret these results. And so one of the tendency that I focus on when looking at Google result is to see these entities as a way to explain the results that we get for that specific query. And of course, the graph that Google has that contains all the entities is on its own. It's has its own ontological feature. And so the more we understand about the knowledge graph of Google, the more we understand of the way in which Google might organize the results and might use the entities to match the user intent with the content. So the theory here is that we could use probably or possibly this network of entities to extract from the corpus of results provided by Google new insights, and these entities might also kind of use for understanding more the pages that rank to the top from the pages that rank to the bottom of the same search results. So here I have two examples of how we can read the web through Google's eyes, and so machine learning on the left, and then knowledge graph on the right. So these are two potential intent that we could rank for, considering the type of content that we have on our test site. And here I have built a small tool and a visualization that you will also have linked to this presentation, and that we will also kind of play with in the next session on over Google Colab. That groups the most relevant entities for these two different queries. So here on the bottom right, you see all the entities that have to do with the query knowledge graph. So these are entities extracted from the result that we get from Google when we trigger the query knowledge graph, in this case, in the United States, okay? And here you have all the entities that you get by analyzing the results of Google when you type the query machine learning. And so some entities are kind of characteristics of the two. And one of the sponsors of this conference will be happy to know that that ontotext is actually one of these kind of characteristic entities that kind of pops up, when we try to analyze the corpus of text of these two queries. Okay. So these are kind of the things that characterize the corpus, okay? And these are the concepts that are, related to machine learning, and these are, the concepts that are related to knowledge graph, okay? Let me quickly show you a little bit of this visualization that we have created here. Because then what is interesting is, of course, where do they meet, right? So what is the overlap? And interesting enough, the overlap, so the kind of the top of the pyramid, it's the entity Google, that has a lot to do with machine learning through, and a lot to do with knowledge graph through. So we can start to see kind of, the way in which a single term, it's kind of present in the search results from the first query and the search results from the second query. Okay, and here we can use this library, which is called scatter text, in order to kind of run through the analysis of the pages behind these results that the Google is using. So we see some tendency, but what about if we take kind of a query like machine learning, and we split the page into two? So we get all the entities from the corpus of the first three results, and then we take all the entities from the corpus of all the other results in the first page. So from number 4 to number 10. We can see that Google, it's an entity that it's not present in the results from number 4 to number 10, but is indeed very present in its multiple occurrences here in the results from the top 3 results. Okay, so we can observe that there is a tendency to use Google as an entity for the top results that we get out of the machine learning when we type machine learning inside Google in the US, and so on. So we can start look at entities that are specific for this page, so everything that is characteristic for this query, and everything that in a way it's specific for the top 3 results, and everything that it's not specific for the rest of the results. For instance, you can see that whether here machine learning is a super broad term, right? It's a broad query, so people expect, probably Google expects and interprets this query as a kind of a generic intent, and so it's providing information that is descriptive, whether more specific content that might have to do with regression and Python and various techniques like clustering, which are more kind of specific, don't make it to the top, because at the top Google is interpreting that the intent is generic, and therefore we have to provide something that it's descriptive enough but not too specific, not too technical. So this is the approach that I am using in order to kind of understand the results from Google. And now I have one more, and that's going to be the last poll for today's session that we can launch. All right. So how is Google using entities? And let's see who has been following so far. And let's see if we get the right answer here, which is not as immediate as it might seem. So we'll take a minute break to go through these, and of course take this time also to ask any questions if things are unclear. Or I think there is a tendency here to answer to the last option, which is the correct one. And I know here there are among you a lot of actually super expert of SEO. So I'm curious to understand if all of these make sense so far, or not. If it doesn't make sense, please write in the chat. Say, Andy, this doesn't make sense. Sorry. All right. So we can. I think we can start sharing the result. Yep. And yes, the results is that Google is using entities for understanding the user query, for expanding the query to improve the quality of the results, and for establishing the relatedness between different entities, using co-occurrences, as we've seen, we've done ourselves with embeddings, and also for categorizing the content using this topic layer that has been defined as a way for grouping entities inside Google within kind of large clusters. And yeah, in reality, I mean, all of the above are actually ways in which Google is using entities. All right, so I will resume the presentation, because we're also getting to the end of the first slot, and probably we'll need to run a little faster in this last part. So the first goal of our long tail strategy is to discover the intents, to find these unpopular query, highly focused, that we can rank for with the content that we have on our website. We might need to model the content, or we might not. I mean, in our case, the content model is as basic as news article and concepts that annotate this news article. We have seen that we can analyze the results out of Google from these queries. So once we have detected an intent that we can rank for, we can use entities in order to analyze the results and to find the entities that kind of are mostly representative of the top results. And as you can probably imagine, we can use these entities to kind of select the content that we have inside the website and create this fully integrated landing page with some AI generated content and some recommended content from George and his colleague journalist writings.
Excuse me, could you please reshare your slides?
Oh, sorry.
Thank you.
Sorry, my fault.
Thank you.
Yeah. So, okay, so yeah, sorry guys, apologies for these. All right, so getting the intent, modeling the content if needed, and then analyzing the results of Google for that specific query, and then based on the entities that we get out of the results, build the page. That's the goal of this session. And let's start with the way in which we can seed the intent. Okay. So the old way is that an editor would go over Google and will start to kind of compose a potential query to rank for and try to look for suggestion coming out of the Google autocomplete. And that's a way that we can use to find potential opportunities, but it's kind of it's a waste of time, because of course you have to iterate through different concepts and try to go to through this suggestion and find something that you can write about. And a lot of us still do this, and so that's the reason why I built this course and this presentation, because I start to envision a tool where you actually provide some ideas, like we've seen before, artificial intelligence, machine learning, and knowledge graph are kind of some potential ideas that we could use for finding an intent. And so, so here I have created this tool that as you've seen before in the call lab, and we will see in the next session in more in details. Now, given a list of ideas like machine learning, artificial intelligence, and knowledge graph, it's capable of extracting queries, okay, and it's also going through these queries with the entities in our knowledge graph, okay, because by doing this, we are able to kind of get an overview of the intents that we can rank for, using the concept that we have inside our own knowledge graph, okay? So here I am grouping the entities, and I'm using the entities of the knowledge graph, like artificial intelligence, to group the intents that I have extracted by iterating through the Google autocomplete, okay? So here I'm saying that, all the intents that I could rank for that have to do with the artificial intelligence are contained here, right? So artificial intelligence definition for IBM. That's a good potential article to write about. Now, the problem when doing these, I mean, there are already tools that do these that you might use that kind of suggest you different ideas for writings. The problem is that first, I want to group them using the content that I have in my site. So here I know that these entities are the entities that I have content for, because they have been extracted from the content that I write. But then second, I need to plug in the search data, because I need to filter out everything that doesn't have search volume. And so here I'm kind of drilled down the original, I think it's 1,300 search intents. I'm clustering them using the entities in my knowledge graph, and then I'm getting the data from the APIs. In this case, I'm using WordLift APIs for the search volume, so I know that there is enough people making these searches, and I can filter out everything else, right? And I can kind of see, I've written something about healthcare, right? And there is volume here. There is some volume at least. Okay, so there's whether here I have a visualization that doesn't tells me if there is volume or no. It only groups the intents. Here I'm looking at the fact that here there is volume So there are people making these searches. And I do have content within the context of healthcare. And then I can choose, for instance, healthcare where, there is, less competition. So there is some volume. I have written about because I do have entities related to healthcare, and there is a limited amount of competition because, of course, I'm planning to create a long tail page that goes after a specific intent, but I know that I'm going to reuse some of the content that I have, so I'm not writing the entire piece. Okay, so this is how we can kind of detect the intent that we can write about. And as you've seen here, I have chosen an area by looking at the entities in my knowledge graph, and by looking at the volume of searches, and by looking at the level of competition that I have within this specific long tail. Okay. There are no tools like these, and this is why I build it. I don't like to do things that already exist. I not like to build new things, and this probably will be made available for free on our website at some point. But for now, we kind of have to get to the end of the session and see how we can now use this insight to build a page. So the existing SEO traffic that George gets, it's kind of, an example can be the article on the interview to Gary Marcus. So where he gets traffic for Gary Marcus, for robust AI, which is one of the concepts that Gary introduced, robust intelligence. So these are this is a human written article that it's getting a large amount of traffic with a series of queries that are quite specific to the content being written. Here, using the methodology that I've explained, I am looking at things like AI in healthcare, or knowledge graph embeddings, or knowledge graph open source, or machine learning versus deep learning, or knowledge graph research, where I don't expect to get an high volume of queries, right? But of course, I can build a lot of these pages that can group a significant amount of different queries, and therefore I can increase the traffic and go after intents that I'm not covering with my premium content. So how do we build the page? So we are going to use, of course, automatic text summarization. And in particular, we are going to use Google T5. Now, one of the elements, exciting part of T5 is a text-to-text language agnostic transformer. So it's a language model that we can use by providing a structure in text, and we can use it for multiple NLP tasks. So as you can see here, I can use it for train a translator that translates English to German. So I have to provide training data in this form with the text in the input and a text as expected output. And I can create a model that does translation for me, okay? Or I can use T5 for instance, creating a summarization. So I can provide a list of text and the summarization for this text, and I can train my model for creating summarization. And that's exactly what we are going to see in action. This is exactly what I have used through the course of this presentation. When I have generated the text, I have summarized content that I scraped from Google results, and I have compressed it using T5 to generate the text that you have seen through the course of summarization, through the course of this presentation. So here we have the two approaches of summarization, and we are using the abstractive summarization. for generating the content, but in some other cases, WordLift uses extractive summarization, and there are, of course, pros and cons of the two approaches. But where are we getting the questions? So we can, so we've seen that we can generate text using T5 by compressing Google results, okay? And we will see in the coming session that, for instance, you know, if I write something like artificial intelligence in healthcare, using this tool, I can scrape the results from Google for this query, get all the text, and then use T5 to generate the answer. So that's an example that I have prepared here, which is the best application of AI in healthcare. And here we have, you know, the generated text that I have derived from the scraping of the results from Google for that query using a language model. And as you can see, it's okay. I mean, it's not too bad. So this is an intro text, but we want to create a page that also have some questions and answer. Okay, so we want to create a page that contains an intro text for the topic that we're targeting, contains a selection of articles, but also contains a Q&A. Okay, and so that's a little bit of the structure of the page that we are planning to build. So we have the title of the page. We have an intro text for that query, and then we have a listicle. It can be a list of your products. It can be a list of, you know, your article that match whatever we see on Google. And then we have a recommendation tool, so kind of a widget that can increase the engagement of the user. And then we have some, you know, frequently asked questions about that topic that can also expand the content of the page. Okay, so that's a little bit of the structure, but where do we get the questions? So how can I get, provided that I have decided to develop a page for artificial intelligence in healthcare, where do I get the questions? So here we can use two methodologies. So the first methodology, and that a lot of SEOs are using these days, is to scrape Google's or Bing frequently asked question, or people also ask blocks in order to get these questions. And so in our examples, in the code that I've written, that's exactly what we do. So before generating the answer, I go out and I seek for, you know, the mostly frequently asked questions about a specific query. So I'm generating the question by looking at what Google is presenting to the user. And then I'm using the summarizer to answer to each one of these questions by scraping the Google results and summarizing the pages that I get. But in some queries, I might not be able to find these you know, frequently asked questions. And so in these cases, what do we do? So again, we can use T5 in this example, and we will use it in the next session to get the context from the article that we have written. So in this case, the context being 42 is the answer to life, universe, and everything. And of course, all the nerds will know what this is. And you see that the output is a combination of the answer and the question. So here we are generating the question along with the answer from our text. And so if we get back to the code, we are generating now the answer from the question that we get from the people also ask. but I'm also generating question from this text here that it's coming from the article that George has written. So Marcus come to AI from a perspective of trying to understand the human mind. As a child and teenager, Marcus programmed computers, but quickly became dissatisfied with the state of the art in 1980s. So out of these texts, now using a pre-trained model that has been fine-tuned for Q&A generation, I am obtaining these questions, like when did Marcus become dissatisfied with the state of computers? 1980s. And then yet one more. From what perspective does Marcus come to AI? Trying to understand the human mind. So as you see, these probably, George would work a little bit before going live with something like this, but it's already a good starting point to structure a page where George is simply kind of revising, whatever the machine has produced. And so we can generate this content using, either the people also ask panel in Google or a language model that can extract questions from the content that we write. Okay. So let's wrap it up. We look at the opportunities. In our case, we look at an opportunities and we look at artificial intelligence in healthcare. We start mapping the content, so we make sure that we have, something like articles, for instance, as a main content type that we can use for creating these pages. And then we analyze the results out of Google to see what are the most important entities that Google detects in the top 3 results. And then we can start creating the page. And the page, as we say it, as this structure over here. And most interesting, we can go directly on WordPress. Where did I put it? And we can see the page that now WordLift has created using all these pieces that we've seen across this presentation. So there is a title that matches the intent that we have detected as a potential long tail. There is an intro text that has been generated in this case from whatever content we got from the web, which is, well, decent enough. Could be better, but it's decent enough. There is a nice widget that people can use for kind of drilling through content that is related. And then there's a listicle of kind of related article like IBM Watson for healthcare and artificial intelligence in the real world. What can it do? Which presumably talks a little bit about healthcare. And then there are some questions like how does AI help healthcare? Now these questions have been created by looking at the people also ask question for that specific query. And that's the generated text that, again, I consider a first draft. So it's not something that I could go live with, but quite quickly, an editor would revise it, optimize it, and then hit the publish button. And also, which is the best application of AI in the healthcare? And here we can see, whatever other answer we have generated using this method. And that's all I have for this first session. And then the next session will be, of course, more about Q&A, and we will go through the code. And that's, again, a quick reminder of the sponsor. So if you want to start playing with WordLift, you can grab the deal by going to a website, wordlift.io/cyberweek. And I think we still have a few minutes for Q&A.
Great. Thanks very much, Andrea. That was really interesting. I even managed to watch properly this time.
Good. So are you starting to use this? You're gonna use the long tail, or?
Not the long tail so much, but I wanted to actually start using some language models to be able to produce kind of like skeleton articles, like
Right.
you described. But yeah, it's like one of these trade-off things, you know. So the time I will invest to actually get that to work for me currently outweighs the time it takes me to write it on my own. So I can do it.
That's true. That's totally true. I'm going to share the link to the presentation so that you can guys have a look at it and get it from here. And then, of course, you are invited in the next session where we can do more Q&A and go through the code for those of you that are interested in understanding, you know, the behind scene type of work. Yeah, of course. I mean, we are kind of automating this process, George, so that it doesn't take a lot of your time, because we know that your time is precious and we want the time to be focused on content, not on machinery, because otherwise we will fail our mission.
Yeah, you know, it's very interesting. It's a very interesting thing to even explore, though, as a kind of hobby. And in that respect, because, you know, I also write code, by the way. I don't just write
Of
articles.
course.
So in that respect, yeah, this is something I've been meaning to do, like trying to imitate myself, basically, like feed a lot of articles that I've written and see if I can train a model that can start to write a little bit like me.
Absolutely, yeah. I mean, that's the most interesting part. I think when we start, even you know, in WordLift we have the extractive summarization, and that reuses, you know, the content that you have written in the article. So it's actually your word. It's not something that it's coming out of something else. It's your word, but it's just you know, synthesized by an algorithm, and it's pretty effective, I would say.
Yeah, one day when, you know, this event organization is behind that, I may find the time to actually do that.
Let me share the screen quickly to show you your synthesis. So if you look at assuming that you have written these, did you wrote these?
This one, yeah, around AI, yeah.
Okay, good. So here, basically, we have this functionality that would use, in this case, a model called DistillBert, that would create, you know, a quick summary that then you can use for the meta description or.
Right.
And we use these on some website for creating, for instance, the story highlights at the beginning with the bullet points.
Yeah, that's super interesting. I don't see any questions from people so far, so I guess maybe we can wrap up this session, and just to give enough time to the operators and yourself and all of the people who are attending the next session to move to that one.
Yep.
Okay, well, thanks everyone. Let's wrap up, and we'll reconvene in like 10 to 15 minutes.
Yep. All right. Bye-bye.
Thank you. Bye for now.
Thank you.